You are welcome to another episode of Data Visualization in Stata. And this particular playlist, as I've said in the first video, contains video on how to do data visualization in Stata using different plots or graphs. And in the first video, I demonstrated how to create or how to visualize data in Stata using the histogram, pie chart, and pie chart. So in this particular video, I will expose you to creating and customizing box pilot in Stata, which is going to be a complete guide to data visualization as far as box plot is concerned. So in case you want to know what is a box plot, which is also called a box or whisker plot, is a graphical summary of data sets distribution. When you are thinking of summarizing your data sets using the graphical approach, then you are thinking of box plots. Of course, pie charts, bar charts, and so on and so forth, they also fall in the same category. But what distinguishes box plots from other ones is that box plots shows the median, it shows the quarters, it shows the range, and it shows the outliers. And as a matter of fact, when you are talking about box plots econometry wise, then you are talking about outliers. So box plots is used basically to show the outliers, the extreme value in a particular data set. So in this video, these are the things that we are going to be looking at. Basic box plot, which shows the box plot for a single variable. Then from there, I'm going to introduce you to different categories, how to use box plots for different categories to compare distribution across groups. And from there, I will take you through how to make use of box plots to visualize two or more variables. And next to that is how to take charge of your outliers. In case you want to remove the outliers, there's a code that you can use. And another thing that I'm also going to show you is how to change the color, the spacing, how to make the line thick or tiny. And from there, I will also demonstrate how to add titles, subtitle, and notes to your box plots. And in case you are interested in taking away the legend, or to you will want to customize your legends, or you want to rename it, I will also show you how to do that in this particular video. And of course, when you have different categories, when you are visualizing a particular variable, for instance income, across region, then you may want to arrange it in ascending or descending order. You can do that particular, or you can perform that particular operation using box plots, and I'm also going to demonstrate that in this video tutorial. And another thing I will show you is how to indicate threshold. For instance, policy threshold. If you have a certain number, to show that if there is an increase beyond this level, there will be an issue, then there is a way we can add that to the command, and the box plots will show the threshold line. And another thing I'm also going to show you in this particular video is how to modify your box plot in such a way that it will show different panels. For instance, you have you want to look at income across gender, then we cannot modify the code in such a way that we have a single panel for male, another panel for female. And at the end of the day, I will come up with a publication ready example, that is a complete code that will visualize a particular variable, add title to it, modify the legend, add notes, change the color of the line, the color of the media range, and so on and so forth. And the last thing I'm also going to do in this particular video is how to export quality figures, or how to export your box plots from Stata environment to a particular document on your system. And as I've said the last time, that you can use different formats, the JPEG, the PNG, the PDF, and so on and so forth. So right now, let us dive into this particular tutorial. Please take note, I've already imported my data. Unlike the previous one where I used the inbuilt data, I used my own data in this particular tutorial. So, and in that particular data set, I have savings, I have region, I have expenses, I have vocational training, I have location, I have gender, I have education, I have children, I have distance, I have age, then I have income. Those are the variables that I have in this particular data set. And in case you don't know how to import data to Stata or into Stata, please check our playlist on Stata. You will certainly see a video there that demonstrates or that will show you how to import data set into the Stata environment. As I've said, the first thing we are going to look at is basic box plots. That is a box plot that visualize a single variable. So for the basic box plots, the code that will be used is this. This is the command graph box. This one tells us the type of graphs that we want. In this case, we want box, not pie, not bar. We want box, and the variable is expenses. So if I highlight this now and I execute, it will give me my box plots. So this is the graphical presentation of expenses. Don't forget, expenses there is a variable. So now instead of showing the data, I've generated the graph, and in this graph we have certain characteristics which I also want to explain. Of course, in the subsequent parts of this video, I will not be talking about it again, except in the case where I want to modify the parts. So the first thing that I want you to take notes here is the median, and this is the median. This is the median. Let me make this bold. This is the median line. This one inside here is the median line. In the subsequent commands, I will tell you how to change the color. So this is the median line, and if I want to check the values, the value of this particular one, you will notice that it is around let's say 20,000 or 30,000, because this is 100,000. So the median is around 20,000. That's the first thing I want you to take note. Another thing I also want you to take note is the interquartile range, which is also called the middle, the 50%. The 50%. You know, here we have, this is the smallest part. So we have from here to here is what we reverse to as the interquartile range, from here to here. And if you look at it very well, the interquartile range is going to be around 10,000, between 10,000 and the highest here. You trace it back to maybe 70,000. So that is the interquartile range. The shaded part is what we revert to as the interquartile range, while the line inside the shaded part is what we reverse to as the median. Now another thing I want you to take note is the lower whisker part and the upper whisker part. You can see above the interquartile range, that's where we have the upper whisker. So between here and here is the upper whisker, and between here and here is the lower whisker. And the most important thing, particularly when you are talking about box plots, you are simply talking about outliers, which I want you to underline here is the outliers. Everything outside the box plots, from here to here is the box plots, upper to lower is the box plot. So everything outside here is outlier, and these outliers must be addressed using different approaches, or you can use a single approach. And in case you don't know how to address outliers, please check our playlist, Stata playlist. You will see you will see a video on how to detect and address outliers in Stata. So just watch that video, you will see how you can address this. So all these ones, 1 2 3 4 5 6 7 8 9 10, they are outliers. So in this second part, we are going to look at how to use box plots to visualize income or expenses across gender. Then in this case, we are going to look at, for male, how many outliers do we have for male, and how many outliers do we have for female. And the codes to do that is this. So the only thing to add to the first one is the over. So you add over and genders. This gender is another variable. So let me show the basic code for box plots. Let me add it here. The basic code for box plots is this. So here we have or let me say variable. So this one is variable. So this is the part you are going to change. And in the case of comparison across groups, then you add over. So this over tells Stata that, okay, look at expenses. I want us to use expenses. Look at expenses and do a graphical presentation for male and for female. So let me highlight this code and execute. So you can now see that we have two box plots, and here we have 0 for 1 for male, 0 for female. So for females now, how many outliers do we have? 1, 2, 3, 4, 5, 6. And for male, we have how many outliers? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can now see, by the time you are doing your explanation, in case you are just analyzing box plots, maybe as an assignment, you can now say for males we have so number of outliers, that is the extreme value. Let's assume the numbers of male that spend more, that they are spending is of the maybe the extreme end, then you can now say they are 9. Then you can also look at the interquartile range, the percentage. You can also compare the median. You see the median here, the median here. You can look at the interquartile range. You will see the interquartile range here is different from the interquartile range here. So you can compare across the groups. That's what that particular this particular code is used for. Box plot by category, and it is used to compare distribution across groups. The group we have here is the gender. We have male, female. We have two groups for gender, and we are also looking at expenses. The next thing that I want to also introduce you to is, now let's assume we have our expenses, then we also have region. We want to look at expenses across group and across region, that is multiple grouping. So now we can use this variable, and instead of you to have 1 over in your code, we can use this code. Instead of you to have 1 over in your code, then you'll be having to, this one will show us the numbers of region. I think we have 5 or 6 regions. I don't know, when I present it you will see we have 6 regions. Let's assume that. Then in each of the regions we are going to look at the gender in each of these regions for this particular variable. So let me highlight and execute. Now you can see, okay, we have 2 groups, the male, the female, and the male. Then the region across the 2 groups, the 6 regions. These are the 6 regions. So now if you want to do an in-depth analysis or an in-depth presentation of your box plots, then you can look at the median across the region for each of the groups. Then you can also look at the interquartile range across the regions for each of the group. And the last thing you can look at is the numbers of outliers. For instance, in the first region for female, we have only 1 outlier. In the second region, we have 2. In the third region, we have 5. And in the fourth region, we have 4 outliers. You can see now that the fifth and the sixth region are free from the problem of outliers because we don't have any outliers here. Likewise here, we don't have any outliers for male. So you can do all those things, all those analysis, and put everything together in your presentation to make your analysis concrete, in-depth, and more convincing. So by the time you present this, your supervisor will certainly be encouraged that, wow, this is a fantastic analysis. So you don't just need to stop as a single box plot. If it happens that you use survey data, then you can look at it. The area you are looking at will certainly be unique. Then you can look at the the outliers, the numbers of people that spend in the extreme edge across the region, across religion, across race, across gender. And at the end of the day, you'll be able to come up with a solid policy that will address that particular group. In case you are looking at their spending pattern, and you are looking at coming up with a recommendation to discourage them from spending so that they can save more, then you'll be able to come up with rigid or an excellent analysis first. Secondly, the factors responsible. For instance, if you are looking at religion, for instance, then you may attribute why the outlier is many for this particular region to a certain religion factor. Then when you are coming up with your policy or your recommendation, that factors that you have identified, then you make it in you write it in the form of recommendation, so that when that particular factor is addressed, the issue of outlier will be minimal in that particular region. So that's why that's the reason for this particular in-depth analysis or in-depth presentation of box plots. The next thing we are going to look at is the reverse case. The other one, the first group is the gender, the male, the female. Then within the gender, we look at the regions. So in this type now, we are going to look at region, and in each of these region, we are going to look at the gender. So let me highlight this. It's just the reverse grouping order. So instead of region coming first, gender comes first here. So when you highlight this and execute, you can now see that we have 6 regions first, unlike the previous one where we have 2 groups. Here we have 6 groups, and within each of the groups we have 2 subgroups, that is female, the male. So now this is just the reverse of the previous explanation that I've done or that I did. So now you can now just look at the region, and within each region you look at those spending or income that is of extreme, right? Then you'll be able to identify the factors responsible for it, and those factors you put it in form of recommendation, so that when a strategy is put in place to address that factor, there won't be issue of outliers or whatever issues you are addressing in that particular paper. The next thing is multiple variables. So far we have been looking at a single variable, income or expenses. Now we want to combine the two together and look at it across gender, and that's what this code can be used to achieve. So here we have graph, the command, the box, the type of graph we want to use, then income, and the second variable is expenses, and we are looking at it across the two gender, male, female. So I highlight this and execute. Now you can see that I have my box plots, which is even a better presentation. So instead of presenting income alone, expenses alone, I put the two together in a single, using a single code. In case you have multiple variables, you can do the same thing. And I did not only stop there, I look at it across different groups. So if I want to look at it across region or religion, whatever I'm interested in, what I just need to do is to change these parts. If I change this to region, and instead of 2 groups, here I will have 6 groups. You can now see that here we have income. This is our income. Don't forget, this is what we call legend. This is legend. Now here is our income, here is our expenses, and for female, which is denoted by 0, you can now see that the income for male is this, the income for male is this, the expenses for male is this, and the other, this is female, 0 for female. This is income for female, and this is expenses for female. And this part we have the income for male, expenses for female. You can just read the code: income, expenses, and 1, as I've said, denotes male, and 0 is used as a code for female. Then at the end of the day, you can write something meaningful based on this particular visual presentation of income, expenses across gender. And as I've said earlier, all these ones outside the box plots are outliers, and you can count all of them. I want to repeat this in case you don't know how to address outlier. Please check our playlist, Stata playlist. Then you will see one of our videos that demonstrates or that shows how to identify and address outliers. The next thing we are going to look at is how to control the outliers. Let me show you the outlier here again. You can see all these ones are the outliers. If I don't want Stata to display all these outliers, what I just need to do is to hide it. I just need to hide it. So once I hide it, Stata will only display the, what is it called, the box plots alone without the outliers. So let me do that using income, or let me change this. Of course I can use income. This is the basic income. Execute. You see the outlier for income. Now I want to hide it. What I just need to do is to add no outlier, no out, that is no outlier, to my code. Once I do that, then I execute. That's what the second code achieved. You see, there's no outlier here. This is just a manipulation, of course, and the box plot clearly show that this box plot excludes outside values, that is the extreme value, which can also be reversed to as outliers. Okay, this is another thing: no outsides, that is no outlier outside. Nothing should be, this one clearly states that nothing should be outside the box plot. You know, I said this the other time that the box plot is from here to here, the upper whisker to lower whisker. So all these ones, all these observations are outside the box plot, and that's why we call them outliers or extreme values. So when I execute this too, it will hide all the outliers. So instead of 400,000, my box plot will stop around 15,000. Let me do that again. You can now see, okay, it's even 10,000 now. So I've like removed some observations from my data, which is not okay. What I just need to do is to address those values. You don't need to manipulate this part. Now the next thing I want to show you is how to change outlier symbols and size. So these are the outliers. So you can see the symbol here. We use circle here. So size is, you can see it's small here. So if I want to make this to be large, or if I want to use, instead of circle, I want to use square, or I want to use triangle, I can do that using this command. So this is the command graph. This is the code, sorry, graph box income. I'm looking at income. The marker, this thing is very, very important. Of course, 1, 2 is very important. The one, just this marker is what gives us the avenue to modify the what is it called, the symbol, the size as well as the symbol, or to modify the outlier, to modify the symbol of the outlier as well as the size of the outlier. So now for symbol, now I use circle here. So that's why the default setting is circle, and the default setting for size too here is small. So if I want to change this circle to, let me say, triangle, I will just need to change circle to triangle. Then here, instead of small, I want it to be large. You understand? So if I execute this now, this outlier, this box plot will change. So let me highlight and execute. You can see, instead of circle, we now have triangles, and it is not only a small triangle, it's a big triangle. If I want to change this to a square, I just need to modify it here. Then whatever angle you want to use, whatever symbol you want to use, sorry, you can just modify here. Then if you want this to be medium, you change this to medium, or if you want the sides to be small, you change this to small. But the uniqueness of this particular modification is that when you are looking at different variables, you want to do box plots for different variables, and you want to add sugar to your tea. Let me put it that way. You want to add sugar to your tea. So instead of using the same symbol for all the variables, or instead of using the same size for all the variables, you can just change it. Circle for one, what is it called, triangle for another variable, large for a certain variable, medium for another variable. So that's just the modification, and it will make your thesis or your project or your paper to be very unique. The next thing we are going to look at is how to change the color. You can see we have navy blue by default, navy blue, but we can change the color. And also, if we are looking at different variables, we can also modify the space between the variables, between the box plots of the variables. Another thing is we can make the line to be either thick, to be either slim, and so on and so forth. But the one I'm just going to show you here is the color of the box plots, and next I will show you how to do that for different variables. So for a single variable, which is income, instead of this navy, if I want to change the color here to red, I just need to modify this part and type red instead of navy blue. Type red and execute. You can see instead of navy blue, I now have red. Here. And whatever, if you want to use pink, you just change it to pink. If you want to use it, if you prefer yellow, you change it to yellow. And also you can use different color for different variables. In this particular code, for this particular code now combines two variables, income and expenses. So, and we are looking at it across groups, that is male and female. So now for the first variable, we want it to be yellow, and the second variable we want to use, let me change this to pink. We want pink. So this is graph, the command, the box, the type of graph we want to use. The two variables are these are the two variables here. Another variable by extension is gender, you can see over, and this box is the command for the modification or the way we want the appearance of our box plots. So let me highlight and execute this. You can now see that we have two different variables and two groups. Don't forget, groups are categorical while variables are numeric. So now we have income and expenses, and for income, this is it. This is our income, and this is expenses. Now the expenditure. So the expenditure for female is this, the income for female is this, and for male, the expenditure, we use pink for the expenditure for male, and yellow for the income. Sorry, we use pink for expenditure and yellow for income. But if you look at it very well, you will notice that the outliers now have different color, because we are not focusing on a single variable. So the color for the outlier for each variable must differ. So that's why we have red and we have navy blue. So if you look at the interquartile range, the 50% range, you will see that the color that we selected here reflected here. Now let's change this to blue, and this to, let's use color red. So now when I execute this, you will see that everything will change. You see, income now blue and expenditure red. So that's about modification of the color, or modification of interquartile range color. Another thing I want you to look at is the spacing. Look at here now. Look at the space between this and this, the space here. If I want to reduce this space, now, what I just need to do is to add gap to my command. You understand? If I add gap to this command now, you can see the space here is a bit big, right? Let me reduce it a bit. Let me add gap to here, comma, gap. You will see that the space will reduce. You can now see that the space has reduced. It has reduced from here to here. It has reduced. We are looking at different categories. This is one category, this is another category. So the space in between the two categories has reduced just because of this gap that are introduced here. So now if I want the space between here and here to be wider, if I want a wider space in between the two categories, what I just need to do is to increase this. Let me put up 200 so that the space can be obvious, or the gap can be obvious. I've changed it to 200. Now let me execute. You can now see that we have a wider gap in between the two groups. A wider gap in between the two groups. So that is what this visual spacing is achieved. In this particular codes, I use a single variable, and look at that single variable too. Here I use two variables. Single variable to achieve a similar thing. The only thing is that we will not have four plots together. Let me execute this. You can see the space in between group 1 and the space between male and female. So this one will reduce the space to, so it just depends on whatever you want to achieve. For instance, if you do this, you copy it or you save it and put it in your thesis, and at the end of the day your supervisor asks you to, why this space is too small, just increase it a bit. Then I cannot say 50, increase it a bit. So I change this to 50 instead of 20, and 20 will give me a fair gap. You can see. Okay, I want the two groups to be very close, so let me just put it, let me make it 1. You see now it will be very close. You see, very close. That's just what this particular code can be used to achieve. Now we have I've shown you how to change the color of this particular part, the interquarter range. Now what if I want to change this color, the color of the median? If I want to change the color, if I want to change the thickness, then these parts will be modified. So instead of F color, that is the interquarter range color, it's going to be line color. You can see line color. So instead of F color, it's going to be line color. I can still combine everything here together, but I just want my explanation to be very clear. That's why I have different line of codes for each of those operations. So now here I want to change the color of this particular line. These lines, I want to change the color of all the line. So instead of black, let me use yellow, something that will be obvious. If you look at it here, you will see that we have, let me estimate normal one first, expenses. Yes, let me execute this. You can see this is expenses, and you can see everything clearly now. Look at the line color, see everything. You see that everything is navy blue, but now I want the line color to be yellow, and also the width of the line, I want it to be medium. Okay, is this one medium? Let me change it to large. So this code will achieve those two things. Look at this very well, then look at the new one. You can see now that all the color of the line has changed to yellow. because this is not that visually okay, but I've achieved something with the operation I performed here. So that's what line color and thickness is all about. Now, if you look at it here, you will see that this is expenses, and this particular expenses you are seeing here is the name of the variable, not the label. It is the name of the variable. Assuming I use exp, what you'll be seeing here is exp. But if I now want to give this particular line a name, then I need to modify my code. I need to add title to it. Not the title that will be here, but the title that will be here. The title here. So that's what this part achieve. Axis customization, and you can see y-axis. This is the y-axis. Then I'm going to add title and scale. Also, if you look at it, you will see that the scale stops at 400,000. It starts from 100,000 and it stops at 400,000. If I want to increase it to maybe 500,000, then I can do that. If I want to change this one to maybe 50,000 too, I can do that using this particular codes. Don't forget, if I'm to perform this operation here, all these codes must be on a single line. But since I'm using the do file, then I have this block to show that okay, everything here is still one. But put it this way so that I can do my execution perfectly, or so that the line of the code will not be too long. So now I want to add the name here, annual expenses in naira instead of expenses. I want it to be clear that okay, here not daily expenses, not weekly expenses, but annual expenses. So that's what this y title achieved, and the y label modify this particular figure that you are seeing here. So you see from here, the highest here is 20,000, the lowest is 20,000, the zero angle, then from 20,000 to 100,000. So by the time I highlight this and execute it, you will see that this graph will looks different. You can now see that here, instead of expenses, I have annual expenses, not weekly expenses, not monthly expenses, not quarterly expenses, but annual expenses. I've labeled my y-axis, and also I've modified the scale. I say start from 20,000 and ends at 100,000. And if I want to make this 500,000, I just need to modify it here, 500,000. Change this to 5, and I want it to start from 50,000 instead of 20,000. Then okay, let me say 10,000 instead, 10,000. Then execute. You now see, of course, it's not that okay because it's too long. You understand these things, so I can reduce this to, for it to be very okay, let me change this to 300,000. Then execute. Okay, it's still fair, but it still shows that this value is just too much. So let me stop at 250,000. 250,000. Okay, execute. Now you can see 250,000. So you can just modify it whatever you want to be highest, but take note, you must cover the extreme values too, so that you will know what value or the figure of that particular extreme. And don't forget, this one, which is y scale 2, tells us the range, that is the interval in between here. If I want it to You can see the interval here is 10 10 10 10, right? So if I want this to be 100 now, I just need to make it 100,000. I will indicate the range, start from 0, and the interval should be 100,000. That is the range. If you subtract this from this, what is going to be the difference? 100,000. So that's what this achieve. So instead of y label, I use y scale. You can see y scale instead of y label. Y title to give the y line name, y label to increase or decrease the value on the y line axis or in the y line axis, and y scale to modify the range, the interval. So let me execute this. We see instead of 10 10 interval, 20 minus 10 is 10, 30 minus 20 is 10. It's going to be 100 interval. So we have 100, 200, 300, and so on and so forth. You can see 100, 200, 300, 400. The interval has been modified. And of course, if I want to log the interval, I just, instead of indicating or specifying a particular value, I just change it to log. So that's why I have log inside the brackets here. And in this case, I don't have range. I just want to the Stata to make use of the log value of expenses. So when I execute this, of course it may not look good. You can see this one presents the log value of it. So the next thing that we are going to look at, which we have partially looked at, is the title. The other time we look at y title, but here we are now going to look at the overall title. The overall title. So I want to do something unique here. So I'm thinking of adding y title to it as well. Let me add y title to it. Copy this, gender, then y title. So I want to add y title to it. So this operation, now look at it. Let me do bus pilot for expenditure. You can see this one, no y title, no title, and for in the case whereby I will group these expenses based on gender, I can add subtitle. That's what this subtitle says. So this is y title, this is the title, expenses distribution or expenditure, whatever, and this is subtitle by gender, just because of this extension, because I'm looking at expenses across the two groups that we have for gender. We have male and female. So that's why I modify the title. Not so I can put everything here if I like, just say annual expenses by gender, but I'm just like telling you that you can introduce subtitle as well. You understand? So this subtitle is noted, but I didn't just stop here. I also want to add note. For instance, if you conduct a study in year 2026 and you happens to administer your survey in the same year, then under each of your graphs you need to indicate the source of the data used for that particular visualization. So that's what this note achieves. So underneath the graph, underneath this under this particular box plot, I will also add household survey conducted in 2026. So everything here, this note adds the source of the data used for this box plot. This subtitle shows that, okay, we don't only have expenses here, but we have expenses across the different gender, male, female. And this title says that the y title text changed the name. Instead of these expenses, we have a new title. So let me highlight and execute this code. Then you have our graphs. You can see we now have expenses, the title, and the subtitle is by gender. Of course, I can say expenses, expenditure, distribution by gender, but I introduce subtitle here. And you can also see the source of the data used for this particular visualization, household survey 2026. If you conduct your own survey, maybe in 2025, you can just put it there, ASUS of it 2025. So you don't need to add this using the test approach. Your graph will pick that particular source. You can do the same for other graphs like bar chart, pie charts, histogram, and so on and so forth, or scatter plots. So this one achieve this. In case you want something like this for your thesis or your project, you can just take a look at this course and execute. Don't forget, if you want to do this using the command window, everything must be on a single line. Now the last thing, which I was not the last actually, the last thing in this particular aspect, title, subtitle, note, is the font size. The font size, do you want the font size to be large or to be small? You understand? Let me put it this way. The font size for the title, let me estimate this, okay, because of this stuff. You can see this font size, I can change it if I want it to be large, or if I want it to be just medium. If I want it to be very small too, I can do that. So here is what I just need to modify. The title is included here. Instead of 2-line codes here or 3-line codes, I have 2-line codes. So this one is the title. It gives the title and the size here. You can see the size here. So when I highlight this and execute it, you can see that this font size is medium here. But if I want it to be large, I just change this to large. So now you will see that this particular title will be bigger compared to what we have here now. Highlight, execute. Now we have a better one. You see, if you want to reduce it, you just change this to small. If you want to modify the title, you just highlight this. Just make sure you include the apostrophe. Then you will have your graph with your title well displayed. Now, the next thing I want you to take note is our legend. I've said this the other time and I showed you the legend in below. So if I want to remove the legend, I can turn it off. Ordinarily, there's no legend here because I'm looking at just single category. So here now, if I want to show my legend, I need to make the variable to add another variable here. So I think I've done that already. So now here we have two variables, expenses and income. So let me estimate this. You will see the legend that will show the color for the expenses. You see the color for the expenses, the color for the income. Let's assume I don't need this. I don't need this particular legend here, expenses, income. I just need to turn it off. Then I will add legend off to my code. So by the time I add that legend off, then I execute this, it will remove the legend there. Also, I can modify my legend. I can change the position. I can change the position of my legend. I can change the label of my legend. Like this, expenses starts with small letter. If I want to make it capital letter, I just need to add legend. You can see add legend. Then income should be for one. Income should be first. Income, not small letter, capital letter. And for expenses should be capital letter. So this particular code modifies the legends. So now let me do this. Let me execute this. You will see that this one, instead of small letter, it will be capital letter. Execute. You now see income, expenses. Another thing is, if I want to change the position of my legend, let me just execute this to do that. You see now this. Then you have it here. You can see where I have my legend now up instead of down. If I want to put it here, I can just, instead of 1, I can say 10. Let me put 10 here and see where it will change to 10. Execute. You can see where 10 puts my legend. So if I want to position it in the middle, then I can change this to 5. Now let's see where it take it to. Okay, it take it down. So that means 3 will take it somewhere. Let's see. You just modify it and you get your desired results. You can see where it puts it now. So in case you want to modify the legend or you want to remove it, these two codes achieve that purpose. Now let's go to another part of it, which is sorting and organizing categories. Ordinarily, when you execute your region, it will start from 1 to 6. So in case you want it to start from 6 to 1, then you can introduce descending to your, what is it called, to your code. This one will start from 1 to 6. Let me estimate this. Income across the region, you will see from 1 to 6, from 1 to 6. So if I want it to be in descending order now, then instead of sort from 1, then I can say descending order. So it's going to be from uh, 6 to 1, 6 to 1. So you can see 6 to 1. Also, if you want to sort from 6, you can just say 6 instead of 1 here. So this one too should give descending. Okay, it doesn't. That means sort start from 1. But if you want it to be in descending order, then this one achieve that. Descending order. This particular code achieve that. Descending order. So you can see income across the 6 regions. And another thing that you may want to do with your box plots is to add the threshold line, which I mentioned the other time. Threshold is very common. For instance, if there's any increase above this level, or if there's any decline above this level, something will happen. That's the threshold line. So you can indicate that, or you can achieve that using this code. We have our command, we have the type of the graph, we have the variable expenses, then the y line. This is where, this is where we have the figure. Here is saying let there be a red line. Let there be a red line wherever you see 5,000, 50,000. This is 50,000. So that red line will come across here, you see. But since we are using a single variable, it's not going to be for all the region. So let's use expenses for instance. You can see the red line, which is dash. That's what this pattern dash. If you don't want it to be dash, you change the pattern here. If I want to change the figure now to 100,000, I just need to put 100 there. If I want to change the color of this line to blue, I just need to change this to blue. Whatever color I want to achieve and whatever threshold line I want to, threshold value I want to give it, I modify it here, the y line. The y line is very, very important because the figure is on the y line and you can see the threshold line. So any increase above this, you can give it your own interpretation depending on the issue you are looking at. So that's how to do a visual presentation of box plots indicating the threshold line. And the another thing we are going to look at is different panels. So far we have been looking at a single panel, a single box plot. Of course it may show different region, but in this case, if you want this to be different panel, like different graphs, like 10, 15 graphs, 6 graphs for region, for instance, 6 graphs, or 2 panel for what's it called, gender, then we can achieve that using this code. So over gender by region, we are like, let it be different region, but the panel should be 2, that is the male and the female. The panel should be yes, male and female across the 6 regions. You can now see we have a single panel for the first region where we have the male and the female. The second region, let's assume this south, southeast, north central, and so on and so forth. So this is graph by region, the 6th region. Of course, we can also graph by gender. You understand? If I want to modify that, I want to have just 2 panels. I just need to modify that and say graph over region by gender. Then I execute this. So I will have 2 panels, different 6 regions. 2 panels, 6 regions. A single panel for female, another panel for male. So that's what this is used to achieve. And by the time you include all this thing in your thesis or your projects or your paper, I bet you your paper will be excellent, and graphically, visually, it will be marked excellent. So the next part is the panel title control, which is similar to what we have achieved with initially under title subtitle. So the panel control just gives each of the panels title. It gives the panels title. You can see all these panels. We have 6 panels, but they are income by region. So when you see it, you know that okay, this is region income by region. This is one region, another region, another region, another region. So if I want to make it income by what's it called, by gender, I just need to modify the code and say graph income by gender, then title will be income by gender. Fine. So now the title will change. Instead of income by region, it will be income by gender, and instead of 6 panels, we'll have 2 panels. You can see income by gender, male, female. So that's that. And another thing, this one is somehow, it's not really straightforward, but let me quickly explain it to you. For instance, we have been looking at expenses or income. Let's now assume that we have income for household. This is the income for household, and each of the household, we are like, how many children do they have? Each household, the first household has 2 children, the second one has 1 child, the third one has 3 children, and the fourth one has just a child. Now, if we are like doing the frequency weight, so Stata will not only be looking at this value, it's going to look at this value for each row, taking into account the numbers of children in that house. And that's what this tells us. This particular commands changes the distribution plus uses, giving more weight to observations that represent multiple units. In other words, the third household, this particular household, we have more weights. Why? Because they have more children compared to the first one that has just a child. So now, in this case, we have a visual presentation that accounts not only for the income, but the children of that particular household. I mean, not only for the income of the household, but also for the numbers of child in that particular household. So when a household has a child, then the weights will be lower compared to that household that has more children, like 3 children. So that's what this command achieved. You can see graph, and this one, the variable that we want to, like the frequency weight, this FW is frequency weight. The frequency weight that we are looking at is children. So now when you are calculating income, please take notes of the number of children in that and look at it across the different region. Then we'll be able to know, okay, the observation here, the outlier here, the range, the median, and so on and so forth. So that's what this particular code achieves. So let me execute it and you see it. You can now see different region, right? Look at the numbers of outliers here. So you can just estimate without children. Then you see that something will change. You can see this bus plot, it has changed compared to what we did when we started this particular video tutorial. So when you want to account for other factor, the frequency of other factor within a particular variable, or then you can make use of this particular command. This one factor in the weights of the children. So instead of just saying 2000, at the end of the day, this 1000 and 2000 will be similar. Why? Because this one has 2 children, while this one has just a child. So at the end of the day, the weights will make it somehow equal. So now, everything we have discussed so far, I have now combined it in a single code. First, two variables, expenses and gender, and I want to sort it from one. Another thing is the color of the interquarter Let me change this to yellow, and the line color to blue, or let me change this to red, the line color of the box plot. Then my white title here, I want it to be annual expenses. Then my weight, my label, sorry, my label from year to year, don't forget from year to year, I want it to start from 20,000 and ends in 100,000. Of course, there will be some outlier outside the box plus because of these limits, but just leave that out of it. Now the y line, that is the threshold that I mentioned the other time. I'll still maintain 50,000, and I want the pattern to be what, dash. Then the line of the threshold, I want it to be blue. blue I want the color to be blue. Then the title of the box plus, I want the title to be expenses expenditure distribution. Let me just change this to expenditure distribution by gender. Because of this over, I'm looking at gender, I'm taking cognizance or taking gender into account in this particular analysis. So expenses across gender, so it's going to be expenditure distribution across gender. And I want to give it subtitle. Don't forget the one I mentioned the other time. So my subtitle, what am I looking at? The median, the interquartile range, the outlier. Of course, the threshold is there as well. The threshold is also there. I may not need to add that anyway, but of course you can add the threshold. That's what the y line achieved, and you can see the white y line. So if I want to add the threshold, I can just copy this and put it here, because the box plus will also show the threshold. So I put the threshold here. Then I want a note to be added when the survey was conducted, the data, the source of the data. So you can just say household survey 2026, and I don't want the legend, the income, the what's it called. I'm not interested in it. So that's what all this code achieve. You can add everything together. This is what we have done so far. Of course, there are some other ones that were not included, but those ones are considered to be not that necessary. But these ones are very important. That's why I put everything together. And once I execute this, you have a well presented graph. You see now, this is the title, this is the subtitle, this is the label of the y line, and this is my y label, and this is the color I give the interquartile range. This is the y line. This is the what is it called? This is the y line. The threshold. This is the threshold. So those are the things that I've discussed so far. The line color, which is red, this is the line color. So those are the things I've discussed so far, or I've demonstrated so far, data visualization using box plots in Stata. And if I now want to export this particular graph, now if I want to export it, I can come here and save as. But if I want to do that using this command, I can just say, what is the title? Expenses, expenditure distribution by gender. Let me put it here, expenditure distribution by gender. I want it to be imported in png fashion, then replace. So once I execute this, it will save. You can see successful. It is successful. So this particular file has been saved in my documents on my own system, and this way, if I want to see it, I will see it in my user, then desktop documents. I will certainly say it's there. I don't need to display that. And if I want it to be in PDF format, this PNG, I will just change it to PDF. Then I will have a PDF format of it as well. So these are the things you need to take notes when you are doing data visualization using box plot. Is just very simple. Watch this particular video from the beginning to the end. So with this, we have come to the end of this particular video. In case you have not subscribed to this channel, please click the subscribe button below, and you will certainly enjoy everything every single video that will be dropped on this channel, and turn on the notification so that you can be informed immediately, you can be notified. And don't forget, if there's anything, any question that you want to ask, you can also make use of the comment section. We will certainly respond to you. And if you want to just appreciate us for doing this particular video, you can put it there. Thank you, we appreciate your video, fantastic, whatever that you want to say. There are some of our subscribers that have been doing that, and when you do all this, it makes our videos to also go viral. And don't forget to share our video with your friends, and in your class too. You can also invite your colleagues, your other students in your class to subscribe to this channel. Thank you. I'll see you in our next video.